I'm going to go over your shocking mystery phenomenon. I'm going to take a souffle cup, put it over a 9-volt battery, and mark where it touches the terminals. Next, I want to take 2 steel push pins and I'm going to push them from the outside in. Where I marked with the Sharpie. Notice they're not in contact with each other. Next, I'm going to fill that up with water. And I'm going to add an electrolyte and sodium bicarbonate. That's what I'm going to add. So while that's dissolving, I have 2 10-milliliter vials. The labels are hard to read, but yeah, I marked them with a Sharpie 1 through 5, so it's easier to see on the camera. But they start at 0 and they go down to 10. I'm going to fill these up with water. I'm going to cover it while it's submerged underwater. And I'm going to invert it into my solution of water and sodium bicarbonate, which is baking soda, without having any gas bubbles in here. Then I see this guy got in there, so I'll do this again. There. There's no gas bubbles in that vial. I'm going to take the other one. Same thing. And now I have 2 completely filled vials covering each of the push pins. So I have a data table set up. Looks like this. So I want to record at every minute, or actually every 2 minutes, the amount of gas, the volume of gas collected from the positive terminal of the battery, as well as the negative terminal of the battery. So I'll do that every 2 minutes. And my stopwatch. And note any observations. So I'll put my battery this way, where the negative terminal is pointing that way, and the positive terminal is pointing that way. I want to be careful that neither of these push pins touch both terminals. They should each be touching only one. or their respective terminal. I'm going to start my timer. And I'm not going to be exact at every 2 minutes, but I'll do my best to record. So notice from the negative terminal, actually both of them, there's bubbles forming, but much more so from the negative terminal. And from the positive terminal, there are flakes of yellowish, brownish, orangish, something or another. So that's another observation. Your job is to interpret these based off the limited knowledge you have early on in this course. Now I'm going to lift these vials up a little bit so we can get a better look at what's going on at each terminal. So clearly you see there's bubbles produced at each terminal. I'm going to try to collect that. Now it's 1 minute and 25 seconds, so another 30 seconds and I'll make my first recording. I don't see. So the first 2 minute, assuming this is not level, so maybe I should take it off and put it down on the table. Make it easier to record. I'm going to pause my stopwatch. And so this is the negative side. You can see that there's gas collecting. That looks like 0.3. Each of these black markings is a milliliter, so about 0.3 there, and nothing noticeable yet on this one. Now there's air bubbles stuck to the side too. So that's a lot of the stuff I want. That's a source of error. So I'll go with like 0.3 and then 0 on this one after the first 2 minutes. So 2 minutes, 0 mils of gas from the positive battery terminal and 0.3. That's my estimated digit, by the way, because these only have markings to the whole number. All right, enough of me talking. I'm going to let this thing run for now for a good 10 minutes or so. Start my timer back up. So while this is going, I want you to think about your observations. Namely, what could these gases be given off at each terminal? We can rule out that the water is boiling, because why would it boil more on one terminal than the other? And on top of that, the temperature of the water is room temperature. So we know water is H2O. So possibly you're thinking that the gases being produced are H's and O's, hydrogen gas and oxygen gas. So we're almost at 2 minutes. I'm going to make another recording, and it is much more visible now. So right at 2 minutes, 4 minutes, I'm sorry, the negative terminal has produced almost 1 mil of gas, and the positive terminal is now readable at about 0.2. 0.2. And 0.2 volume mils of gas for the positive, and let's go with 0.9 at the negative terminal. Still going pretty good. So let's discuss. Water is H2O. So you might be thinking that means there's 2 hydrogens for every 1 oxygen. Maybe hydrogen gas is being produced from the negative terminal of the battery. And maybe oxygen is produced at the positive terminal of the battery. So we might expect that at the end, or near the end, there to be twice as much gas here than here, because there's twice as much hydrogen in H2O as oxygen. So we'll see about that. We're coming around another 2 minutes. So make another recording right now. I'm going to show you in contact with terminals. They are just bubbles when you observe they weren't. Right. Oh, no, it's over. It's over. All right. So at another 2 minutes, maybe the positive side is about 0.3. Not much of a difference. Now on the negative terminal, it's maybe 1 point at the bottom of that meniscus, maybe still 1.1. I think before it was 0.9, so we did get some more gas. All right, so let me write that down. At 6 minutes, positive is 0.3 milliliters and negative 1.1. All right, so we keep on this. So we expect maybe twice as much gas on this side, and we're not getting that so far. We're getting much more than twice. So that takes us to, well, that's related to why this solution is turning brown. So maybe you're thinking because the push pins are made of steel, which is an alloy of iron, and it's rusting on one side. So then my follow-up to that is, well, why is it only rusting from the positive side, the left, this side? That's where all the yellow is coming from. Why might that be? Well, we haven't learned enough concepts for you to know that, but you might take a guess at why only one side, or one of the terminals, namely the positive side of the battery, is producing this yellow color discoloration. All right, so think about it. I'm curious to know what you think. Now, at some point, no, I missed my next time here. Let me jot down. It's at, all right, so now we're clearly seeing some gas accumulate on the positive vial. The vial, that's about still about 0.3. Hasn't changed much. Now on the negative side, we're almost at like 1.5 mils. Let me jot that down. So it's 0.3. Doesn't change much. The positive. Anyway, 1.5. Okay. Right, so you might think, well, it's again, I think the light comes from positive. And next, bubbles are being formed in both vials, but the bubbles in the bubbles in the vial attached to the positive side are much smaller, seems like, and the bubbles attached to the negative side are much larger, and they're also sticking to the walls of the tube. That's a source of error. So why might that be? So I'm going to my last few recordings all there. I'm going to show you how to graph and make. I'll show you how to make a graph. Sorry, guys, but these bubbles come out. One last recording off there. All right. That's it. Here's what my push pins look like afterwards. The push pin on the left was the one that was connected to the positive side of the battery, and the one on the right is the one that was connected to the negative side. So this supports the idea that at least one of the push pins was rusting. And this is directly related to why there was less than the 2-to-1 ratio of gases being produced. In fact, much more or less of the oxygen gas from the positive side of the battery. And that's because a lot of that electricity was going into what we call oxidizing the metal, in this case, iron. So we'll learn more about that when we get to our lesson on oxidation and reduction reactions. And if you've taken a little physics, you might even make the connection from this electrolysis of water to Faraday's law, which relates the amount of charge being passed through to the amount of whatever it is that we're trying to make, in this case, gases or iron ions. And finally, I'm going to walk you through how to make a graph using the data that we collected. Now, I formatted the columns with the volumes of gas to have one decimal place because that's how many significant figures we needed. And the way I did that is I selected the columns with that data. I went to Format, Number, and I went to Custom Number Format. And I deleted the extra zeros after the decimal, so we only have one. All right, so let's select our data. And one common thing I see students do is the cells that have your measurements, they need to be numbers. In other words, you can't put like 0.00 or 0.0 and then add a unit to it, because then the spreadsheet treats that as text. And we need to have the spreadsheet treat these cells with data in it as numbers. So let's select our data and then click on Insert, and you want to go to Chart. I'm using Google Sheets, so it's similar if you're using Excel or something like that. So there's our chart, and we can put trend lines on here and all that, but this has turned out pretty good. And so you might say the red graph represents the hydrogen gas produced at the negative end of the terminal of the battery. So we might even relabel this as H2 and O2. So you can take a screenshot of this, print it out, and add that to your lab report before you turn it in.